All right. I have updated your grades, so you check on Canvas. You should have the most recent stuff put in. I need to make an announcement about, when is it? What day is that? Thursday? Is it Thursday of next week? Thursday, yes. Thursday, 7 to 15. No class that day because I plan on partying on Wednesday night and I don't want to come in on Thursday. No. I didn't know this. 4th of July holiday, they're giving Thursday off for all of the campuses. Yeah, they probably don't know that. Yeah, I looked at the calendar. It says it's a holiday unless I misread it. Let's look, just so you can have proof. I already looked, but yeah, but now that you're saying you have a test, I'm second guessing it. But so if you go to the main website, you go to admissions and go over to academics, and you go over to calendar. And this is 2000. Let's see, we're gonna get down to summer here. Summer 2015. Maymester, no. First summer session, no. 8-week summer session, yes. Right? We're in the 8-week summer session. July 2nd, Thursday, Independence Day, holiday, college closed. So unless that's a mistake, we have Thursday off. All right? I did not anticipate that, so the calendar says something different. That's the first announcement. The next announcement is that on Tuesday of next week, right? What day is that? 6:30? Is exam 1. Exam 1. Someone's got to bring the humor. I appreciate that. So, I did. Did you get your emergency taken care of? Okay. All right, good. Well, that's all we have planned for that day. I gave a test in my Cal 2 class today. The first half they took the test, and then after that they had to stay, and then we lectured the rest of the way. So I'm not going to do that to you. I'm just going to give you the test. Is that okay? Is that all right? On Tuesday, before the test, I'm in a class. To take it. Not really. No, because I get here and I'm in class right away, like in the morning. Oh, how early are you talking? I'm in this class. I'm in this room from about 1 o'clock till 2 o'clock. So you could come in an hour early to start it. Yeah. My class before this ends at 12:30. I usually eat, and then I'm here. So if you wanted to start early, you could. Okay. Oh, well, you know what? No, you cannot take it early. That's it. We need to get going on material. Because you promised me, right, that you'd be ready today? You promised me? Where the heck are they? There we go. We ended class. I gave you those problems, and then we worked them out on the board, right? Remember that? Now, what I've done to start the review, oh, y'all can move those desks if you want to slide them over. You're like, oh, like that. What we can do, or what I've started to do, and this is not complete, but to give you some sort of reference, what you should look at to prepare for the test. These are the 2 packets that the test covers, the review packet and then the test 1 packet. And I went to each page out of the homework assignments, and I picked for each page what problems you should focus on. That narrows it down a little bit for you. All right? Now, I'm not saying that I guarantee you that the test problems are going to be just like those, but if you study those concepts, you should be okay. All right? That's what I'm telling you. In addition to that, whatever we get through today, which I will, at the end, I'll go through the homework and I'll tell you which ones we would add to that list. Everyone understand how that list works? Page is on the left, what number it is on the right, and then over there I didn't write that down. Page on the left, number on the right, and then I ran out of room. So that 3918 top right corner means page 39, number 18 in the test packet 1, or the test 1 packet. We all clear? Okay. All right, now we are going to talk about, we've already talked about lines. We know how to graph a line if it's given to us as an equation. And what we want to do now is talk about parallel and perpendicular lines. So parallel lines have slopes that are what? When you talk about parallel lines, they're the same slope, right? Parallel lines will have the same slope. Does that make sense to you? So they have slopes that are equal. And remember, we're talking about lines now, so more than one line, plural. If I just give you one line, I can't say, is that one line parallel to something unless I compare it to something, right? So I need 2 lines in order to talk about being parallel. So if you have 2 lines, you want to know if they're parallel, you look at their slopes and you ask yourself, are they equal, right? If they're the same slope, then they're parallel. Perpendicular lines have slopes that are, and this one's a little more tricky, negative reciprocals. Negative reciprocals. What does reciprocal mean? Like if I give you a number, you flip it over, right? That's the reciprocal. If I give you 2/3, the reciprocal is 3/2. But not only is it the number flipped over, it also has to be opposite in sign. So you might want to look at this word here, instead of being negative, to be opposite. Because if the first line has a slope that's negative, then your perpendicular line would have to have a slope that's positive. So you can still say negative reciprocals. It's technically correct, but I think it'll make more sense to you if you just remember they're opposite signs. All right, so what is the negative reciprocal of 4/5? Negative 5/4. What is the negative reciprocal of 8? 1/8. 1/8. So you have to remember that negative 8 is negative 8/1, isn't it? And then what you do is you flip it over and you change the sign. So flip it over, it becomes negative 1/8, and then change the sign, it becomes positive 1/8. We good? All right, determine if these lines are parallel, perpendicular, or neither. Remember, it's all about the slope, right? I didn't write this. It's all about the slope. So are these lines parallel, perpendicular, or neither? So the slope of the first line, right, is what? So I'm going to call it M1. Is that okay? It's the slope M, but 1 for the first line. That's equal to negative 2/5. The slope of the second line is what? The number in front of X, right? So 5/2. Are these equal? No, right? Are they negative reciprocals? Yes. Because they're negative reciprocals, perpendicular. Understand? Questions? What if this one What if this one had been negative 5 halves? Would they have been equal? No. Would they have been negative reciprocals? So, neither. Look, if you have two lines, they can be parallel, right? Perpendicular, we didn't even talk about, it means that they intersect at a cross, right, like a 90-degree angle. But couldn't you have something that is not parallel and not a cross? That would be the neither case. Oh, on these things over here, if you just want to take a picture of the board at the end, you can, all right? Don't expect you to write all that down. Find the slope of a line parallel to the line passing through these points. What? Yeah, you have 2 points, right? Negative 6, 2 here, 3, negative 4, which is somewhere around here. Those 2 points have a line that goes through them, right? It just wants you to find the slope of any line that would be parallel to that one. So you just need the slope, right? And because it's parallel, the slope of the line that we would be looking at would be exactly the same as the slope of that line. Because parallel means equal. So what is the slope of that blue line there? Rise over run? y2 minus y1 over x2 minus x1, right? That was our formula for it. So negative 4 take away 2 over 3 take away negative 6. You recall doing this? We labeled these x1, y1, x2, y2. Remember that? We label the points. We use the formula. We're very careful with our signs. What's this? Negative 6 over 9. And that can be reduced negative 2/3. So is this our answer? That's the slope of this line, right? We want the slope of a line that's parallel to that one. No. We're here. We are at the answer, but let's just make sure you understand why. This is the slope of that line, right? It's asking us to find the slope of a line, any line that would be parallel to that. Well, then it would have to be the same slope, wouldn't it? Which means that's our answer. The slope of that line is the slope of our line, too. They share the same slope because they're parallel. So that's the answer. Now, look at the next question. Find the slope of a line perpendicular to the one we just worked with. So that's the slope of this line. It's asking you for just the slope of a line that is perpendicular to that. So what would it be? 3 over 2. It would be the negative reciprocal of that. Flip it. Because it's perpendicular, negative reciprocal. All right. Is the following equation of this graph parallel, perpendicular, or neither to another whose slope is negative 1/3? I'm sorry. I did this just, the writing of this is, okay, they say, is the slope of this equation, what they're talking about is this. All right, this is a line, isn't it? We could graph this. This is what we did on the board the other day. All right, it says, is that graph of this line, is it parallel, perpendicular, or neither to a line who has this slope? So what do we need to do here? Find the slope of this line, right? And compare it to this one. Yes? How do you find the slope of this line? Get the y by itself. Yes. So to get the y by itself, I move the negative 3x to the other side, which makes it positive 3x. I have to take the 2 off the left side, so subtract 2 on both sides, and you should get plus 8. Yeah? What's the slope of this line? The slope of this line is 3 over 1. How is 3 over 1 related to negative 1/3? So they're not equal, right? They're not equal, so these lines are not parallel. Are they negative reciprocals? Yes. If you take this one, flip it over, and make it positive, you get this. If you take this one, flip it over, and make it negative, you get that. They are negative reciprocals, which means these lines are perpendicular. Understand? No questions? Hold on a second. I'm just going to look at this. All right, let's do this one. Find the slopes for the following equations. So find the slope of this line. That is a line, right? So we find slope by isolating y, right? Getting y by itself, putting it in the slope-intercept form. Let's see, you might do this, move the x to the other side, and then divide both sides by -3. What happens when I divide this right here by -3? What's the number out front? 1/3, because you'll have negative over negative, which would be positive. And then when I divide the 1 by -3, I get -1/3. So what is the slope of that line? 1/3. That's our answer. Now do the same thing on this one. Get y by itself. I'm trusting that you could take this linear equation now and get things moved around. I'm not showing that. I added 3x to this side and added 3x to this side. Yep, and then I subtracted 4, subtracted 4. What's the slope of this line? -3. All right, that's the slope. So now it's asking, are these parallel, perpendicular, or neither? Perpendicular. Because the slopes are negative reciprocals, aren't they? Why don't you try this one? Do this one on your own. Solve for y on both of them. Compare the slopes. See what you get. relationship between those two lines? So get anything? I've heard parallel, I've heard perpendicular. Neither. Looks like we're getting all right, let me try this one here. You get negative 3/5 y equals negative x plus 1. So that's just moving the x over. How do you get rid of negative 3/5 in front of y? Multiply by its reciprocal, which is just negative 5/3. Yeah, I'm going to multiply negative 5/3 on the left side. And then whatever I do to the left side, I must do the right side. Understand? Coming through with that? Now the reason we do that is because negative times negative is positive, right? And you'll get 15 over 15, which is 1. So that just gives you y equals, and then over here, distribute this through. What's negative 5/3 times negative 1? 5/3 x. And then negative 5/3 times 1, negative 5/3. So the slope of this line is 5 over 3. Understand? On this other equation, when you subtract 3x on both sides, it gets a negative 3x on the right. And then when you subtract 4 on both sides, you get 0. So getting y by itself, I divide both sides by 5. Get negative 3/5 x. Questions? What's the relationship between these slopes? They are perpendicular lines, right? Negative reciprocals. So these two lines are perpendicular. No one has questions? Okay, so to my question over there, do two parallel lines, lines, it's supposed to say lines, ever intersect? No? I wouldn't be asking if there weren't something more to that, right? There's got to be something more to that. Okay, so you've been taught that when you take a line and you take another line, in order for them to be parallel, they have to have the same slope, right? But visually, like spatially, we realize that those two lines don't hit each other, right? Okay, so with that in mind, I want you to check out a drawing that I'm about to make, all right? I'm going to draw a street with some buildings. That's my road. That's my buildings. I have a couple of buildings on the side of the road. See it? Yes. Looks like I'm looking down from the top, right? That's a very flat picture, isn't it? It's like that's the best I can do on a flat sheet of paper. Notice the lines that are parallel. All these little line pieces are parallel, aren't they? Everything in yellow is parallel in my drawing. Okay, next to this, I'm going to remind you, if you've ever taken like an art appreciation class or anything like that, or if you've ever seen cave drawings, like the drawings that old cavemen did, they suck, don't they? I mean, they're not good pictures. They weren't good artists, were they? I mean, we could almost say it's almost like a kid drawing a person, right? Very, very basic stick figure, two-dimensional, right? Are any of you artists or enjoy drawing? Can you draw like faces three-dimensionally and stuff? Yes? You're pretty good with that? See, I can never do that. That's much more challenging than just drawing a stick figure, right? All right, so what's my point? My point is that if you look at art nowadays, it's much more realistic, right? If you have a flat sheet of paper and you're trying to trick your eyeballs into thinking it's real, like three-dimensional, then all of this stuff that you're learning about parallel lines has to be thrown out. It can't work that way if you're going to make it look good. So let's now imagine you're standing on a train track, and this train track is straight and it goes forever, and it's flat, and you can see as far as the horizon. What does it appear the train track does? They look like they intersect. We know physically they don't, but what does your eye think? That they go to a point, right? Yes? So if I'm going to try and draw this image and trick my eyeballs into thinking that this is three-dimensional, I cannot follow the rule that parallel lines don't intersect. I actually need them to intersect. So what I'm going to do, I'm going to draw the same picture. And I'm going to pick a point way out, way out, which we call the vanishing point. Thank you. That's called our vanishing point. And this is going to be the horizon. All my parallel lines, all those ones in yellow, must go to that line. So here it comes. There's my road, okay? And now I'm just going to go quick because we don't have time for the rest of this. You get the idea? Okay, look at all my parallel lines. No, I'll do it in a different color. All my lines that were parallel are now going to the vanishing point. And so what I've done is I've created that three-dimensional effect. But to do it, I had to break that rule, didn't I? Yes? Okay, that rule is correct. Two parallel lines do not meet as long as you're talking about what's called Euclidean geometry, which is the math that we do in all of our math classes, till you get way, way past calculus. Then you start talking about, well, what if you don't want to do Euclidean geometry? This is called perspective geometry. And so what happened is as people became more intelligent and we started to advance, we started to realize this. So we can't really blame the cavemen because they were doing the best with what they knew. Later on, we realized that there was a lot of mathematics behind this and that we would have to change the structure of everything in order to be able to trick our eye. Y'all don't look very excited about that. But, so, do two parallel lines ever intersect? It depends on what geometry you're in. Just depends. For us, yeah, they never intersect. Okay. Write an equation for each line described in slope-intercept form. So what I want you to do is write the equation of a line, right? Be very careful, understand the directions. Write the equation of a line. That means you want to come up with an equation that looks like this. Y equals mx plus b. The only things that you actually have to determine are what m and b are, right? If you know what m and b are, that's a particular line. Here's the information they give you. First, they give you what b is, don't they? So you already have half of what you need. The only other information that you need to figure out is what m is. So I'm trying to find the equation of a line that is perpendicular to this line, but has this y-intercept. So if I'm going to be perpendicular to this line, what am I going to have to do? How am I going to use this information right here? I have to be perpendicular to this. Solve for y. That'll give us the slope of that line, won't it? Is that the slope that we want to use? Negative reciprocal? Yes. So I'm going to take this equation right here. I'm going to solve it for y. So move the negative 10x to the other side. Becomes positive 10x. Divide by 2. And so what I know is that the slope of this line is 5. I want my slope to be perpendicular to this one. So my slope needs to be what? Negative 1/5. So from this, negative reciprocal is going to be negative 1/5. And that's going to be the m that we use, right? That's the m that we're going to use for our line. So somebody give me the equation of the line that we want here. Negative 1/5 x. Then what? Minus 2. Minus 2 came from the fact that they gave me what b was, didn't they? So if I graph this line and I graph this line together, they should be perpendicular. And this one should go through negative 2 on the y-axis. The next problem is exactly the same, except instead of being perpendicular to a line, we want to be parallel to it, which means we have b already, right? And we're going to figure out what m is for this one. Negative 5, right? And then what do we do with that slope? Nothing. We use that slope exactly as it appears because we want to be parallel. So just from this, because it's solved for y already, I don't have to do much work. I know that our m is going to be negative 5. And then write the equation now. Y equals negative 5. That's our slope, x plus 1. Do you have any questions? No? Yeah, this probably should have been the first. They probably should have done this one first and then the other one next, but this one was a little easier. Hey, what's up? Oh, homework. So let's go through this. Let me tell you now which ones that you should look at. Oh, wait, hold on. I think I already did this one. 49, 50. I already did this. 50. Yeah, sorry. I already told you on here what you should do. And I put a little star next to 49, 3 through 13. Those were the problems here that we did in class, some of them. You've got to be able to graph a line for me on this test. I mean, that's like one of the main results. When in class last time, I had everyone do the ones in yellow, and then if they finished in time, do the ones in blue. So we did all the ones in yellow and in blue in class on the boards at the end of class. All right, what else did I have on there? 14, 15, 16. So look, 14, find the slope of a line going through these 2 points. And then the slope of a line which is perpendicular to it. So you're going to find the slope, right, using the formula. That'll be the slope of that line. And then you do the negative reciprocal to talk about a line which would be perpendicular. This problem is just like the one we just did, just now. Except, you know how we had to solve for y and figure out what m was? They just give it to you. You already know what the m is. What? Wait, that's weird. Goes from 16 to 8. What's up with that? All right. Moving right along. The characteristics of graphs of linear functions. When we go to plot or graph something, a line, we usually want to have at least 2 points. And we did this in class last time, right? We graphed on the boards. But I had kind of jumped ahead a little bit. Now it's like formally going through and showing us how to graph. You find 2 points, you draw a straight line. That's it, right? That's all you do. So let's get to a problem that would be more applicable. I'm just looking here. Okay. So what I want you to do here is let's graph this line right here, but we are not going to do this table, all right? Because that's not what we did last time. What we did was what? If we wanted to graph a line, what do we do on the boards? Put in slope-intercept form. Y equals mx plus b. So solve for y. Solve for y here. And divide both sides by 2. So remember when you divide by 2, right? Everything gets hit with the 2. So it's 3 halves x, and then the 4 divided by 2 is 2. And then what did we do from this? You got your slope and y-intercept. So the slope here is 3 halves. The y-intercept is 2. So what piece of information should I put on my graph first? The y-intercept. Always start with the y-intercept. So I'm going to go to 2 on my graph on the y-axis, which is there. And from that point, up 3 and right 2. So just jot up 1, 2, 3, right 2, 1, 2. And you break out your ruler, straight edge, whatever it is, and you draw your line. Now, they say you can get 2 points is fine, but 3 points is even better. So if I wanted another point, what could I do? Down 3, left 2 would take me back to where I was, right? Oh, from the starting point, I could have gone down 3 to the left 2. Or from the point I'm at, couldn't I just do that rise and run again? Either way. I'm going to start from where I am. 1, 2, I'm going to go 3 up again and 2 over again. And hell, if I wanted 4 points, I could do another one. I am using the y-intercept to start with. That doesn't count. Well, that was 1 point, right? And then we moved up and over, that's 2 points. And then up and over, that's a 3rd point. No need to apologize. There it is. Let's try this next one. You try that. Are you all getting that coefficient in front of x? You have to divide negative 1/4 by 2. What is it? I moved this over, right, which made this negative 1/4 x. Then I'm going to divide both sides by 2. My question is, what is this negative 1/4 divided by 2? Because that's the most tricky part. Let me divide by 2. What is reciprocal, but what's 2? I have to write it as a fraction first. Like that. And now flip it. So forget the 2 over 1. Flip it up here as a multiplication. Put it as a 1 over 2. And so it's negative 1/8. I just want you to be careful with that. If you have to divide a fraction by a whole number, remember, make that whole number a fraction, then do your flipping thing. Any questions on that? Okay, so where am I going to start from on my graph? Positive 1 on the y-axis. From that point, you want to do rise over run. Where's the negative live? On the top or the bottom? Where do you want it? You want it on the top or bottom? Yeah, I just want to make sure you're clear. It's either one. You either have top or bottom. So I heard someone say up 1. So I would have to do it that way, right? Up 1. So the negative would live on the bottom. So from this point, I'd go up 1 and then left 8. So up 1, and then 1, 2. Well, it's one or the other. So I'll write underneath, what if we had done it this way? That would have meant what? Down 1, right 8, and that would put us here. But they all live on the same line. That's the good news. I mean, either way you do it. And then draw your straight line there. No. I mean, make your line a little better than mine. I'm trying to draw on glass with the thing. It's a little harder for me to do. Okay. I mean, you could just like fold up a piece of paper, right? Just use that. All right, x-intercepts. Where is it located on the graph? Where is an x-intercept located? So it's on the x-axis? Okay, what is it about any point that lives on the x-axis? What's something that you know about any point on the x-axis as far as the ordered pair? That the y is always 0. And the x-coordinate, well, you don't necessarily know that. But you know that if you're going to be talking about an x-intercept, where a graph hits the x-axis, then that point must live on the x-axis, which means the y-coordinate has to be 0 in order for that to happen. Agreed? What about the y-intercept? It lives on the y-axis. And what can you tell me about the ordered pair for any y-intercept? Yep, 0, question mark. You know that the x-coordinate is 0. Again, if you're on the y-axis, right? If you're on the y-axis, then the x-coordinate must be 0. If you're on the x-axis, then the y-coordinate must be 0. This is very, very useful to us, because let me show you what we can do. Look at this equation right here. We know this is a line, right? We know that we could sketch this. I would go to 9 on the y-axis. From there, I'd use the slope, wouldn't I? Couldn't I do that? But what can you tell me about the x-intercept of this? Well, for the x-intercept, we know that for any x-intercept, which value must be 0? The x or the y? The y. So let's get this straight. If you want to find the x-intercept, you actually have to let y be 0. If you want to find the y-intercept, you would have to actually let x be 0, so they're opposite. So if I want this x-intercept, what I'm going to do is I'm going to go to this equation right here, and I'm going to let y be 0 and rewrite the problem. It would become 0 equals negative 2x plus 9. Can you now tell me what x is? How? Okay, so move the 9 to the other side, subtract 9 on both sides, and then divide by negative 2 on both sides. And don't you just get 9 halves? 9 over 2? So as far as x-intercept is concerned, when we let the y be 0, the x turned out to be 9 over 2. Yes? Now, I don't have enough space, so I'm going to have to do it to the right. How about the y-intercept? What do you do to find the y-intercept? You set, this time, the x equal to 0. Right? So go write down your equation again, but this time replace the x with 0. And what do you get? Y is 9. So for y-intercept, we always know that the x is 0, and in this case, the y is 9. Now, I think you would agree with me that we have 2 points now, don't we? And we can plot the 2 points. And once we have 2 points, we can draw a line, couldn't we? So you could almost look at this as being another way of graphing lines. Although, in my opinion, it would have been a lot easier to do it by just going to 9 and then going what? Like down 2 over 1 using the slope. That would have been much faster to graph the line. But this is another way. All right, let's see about this one. For this one, I'll get you started. I'm going to replace the left side f of x with y. And you go ahead and work these out. Try and figure out the x and y intercepts on those. And let's say it verbally one more time. If you want to find the x-intercepts, you set y equal to 0. If you want to find the y-intercept, you set x equal to 0. Anybody get 28 thirds? Yes? Good. For the x-intercept. 28 thirds. And then do the y-intercept to see if you get that. -7, right? Would you agree it was very easy to get the y-intercept? Because the x part just went away and then whatever was out there was our y-intercept. Do you see why now? That in that form y equals mx plus b, do you see why the b is always the y-intercept? Because when you replace in that formula, where is it? Well, if you take this formula right here, and I say, find the y-intercept, the first thing you're going to do is set x to 0. And when you do that, it's going to kill this. And so you're going to say y is b. So that number b is always the y-intercept. That's kind of why. I think you might also agree with me that finding the x-intercept was not terribly difficult, but kind of a little tedious, right? Especially if there were fractions involved. So whenever you have an equation, a linear equation, where it's already solved for y, just be prepared to have to work a little bit to get the x-intercept. Let's look at number 6. Notice on this one, it's not solved for y, right? Do not solve it for y, because we're asking for x and y intercepts right now. We're not asked to graph it. Find the x and y intercepts. Look at how easy it's going to be to get these. What's the x-intercept? What do? Set which one to 0? Set y to 0. And when you do that, you're just going to 8x is 17. Divide both sides by 8, you get 17 over 8. That wasn't too bad, was it? It just kills off the y term, leaves you 8x is 17. So my x-intercept, I set y to 0, I get 17 over 8. The y is 0. How about the y-intercept? Be careful with this one. For y-intercept, you set x to 0, right? And so now this x term goes away, right? The 8x right here, that goes away. And you're left with 5y is 17, which means that y is what? 17 over 5. Are we all very crystal clear that if you want to find x-intercepts of a line, you set y to 0, and if you want to find y-intercepts, you set x to 0? Okay. Okay, well, let's do them mentally. Let's find the x-intercept. So set y to 0. Remember the left side is y, right? Set y to 0, which means x is 6. And then to find the y-intercept, set x to 0. And you get y is what? 6. 0, 6, 6, 0 are the y and x-intercepts respectively. All right. The zeros of a function. Definition. What are the zeros of a function? Okay. If you have a function, so we do not necessarily have to be talking about a line right now, just a function. Remember, functions don't have to be lines, but a line is a function, but here we're not restricting ourselves to that. Let's say we have a function. Well, is that a function right there? How do you know that's a function? The this test, yes. It passes the this test, which is the vertical line test, right? It passes that test, so it is a function. The zeros of a function are the points where the graph touches the x-axis. Crosses through or touches. It doesn't have to cross through as long as it actually hits the x-axis. Yes, the points when the function equals 0. It's the points when the function equals 0. Where do they appear? Where will all of the zeros of a function be? On the what? On the x-axis. So when you talk about intercepts, okay, let's make a distinction. When you talk about an intercept, it could be x or y intercepts. When you talk about the zeros of a function, you are actually talking about the x-intercepts only. So saying the zeros of a function is the same as saying the x-intercepts. Remember, the answer is always the x-coordinate that's supposed to be x-coordinate. That's what this is, x-coordinate. I'll show you when we do an example what I mean. At most, how many zeros or x-intercepts can a function have? This is a trick question. It's unlimited, right? You could have as many as none, and you could have any number of them, right? No limit. There's no limit to how many x-intercepts a function can have. I mean, I could draw a function that looks like this. Something that passes the vertical line test, crosses the x-axis a bunch of times. Now, on the other hand, how many y-intercepts? At most, how many y-intercepts can you have? 2? 1? Why can't you have more than one y-intercept? Yeah, that's right. Think about where are you? Come here. That's right. If you try and draw a function and you try and draw more than one y-intercept, then it will fail the vertical line test, won't it? Those 2 points will lie on the same vertical line. So it's impossible to have a function with 2 y-intercepts. Is it possible to not have any y-intercepts at all? Yes. You cannot have any. So you can have none, you can have 1, but that's it. So the most you can have, 1. But I'm going to put next to it or none. Okay, it is possible to have none. Find the zeros of this function, of these functions. So look at the first one. How do you find the zeros of a function? It's the same as find the x-intercepts, right? You set y equal to 0. In this case, y is the left-hand side, isn't it? Solve for x, you get x is what? 6. Now, what we will write is x is 6. Notice I'm not writing it in an ordered pair. The 0 is always going to be written as the x-coordinate only. X is 6. We already know y is 0. It's the 0 of the function. It's where the function's spitting out 0. Next one. Replace y with 0 again. X is what? What is it? 6 goes into 90 how many times? 15. So x is 15. Questions? If you wanted to write the actual point, it would be 6, 0, and the next one would be 15, 0. All right, so I said earlier that you could look at the x-intercept and y-intercept as an alternative way to graph something. So take a look at this one. And let's not actually do it, but let's talk about if you were going to do it going slope-intercept form, you'd have to solve for y, wouldn't you? So you take the 2x to the other side, then you divide everything by what? -6? Yes? Instead of doing that, let's just find the intercepts quickly. How do you find the x-intercept? Replace the y with 0, which would just give you this, wouldn't it? Which is 6. Do you see how quick that was? So I just go to my x-axis and I put a 6 there. At the 6 on the x-axis, I just throw a point real quick. How about the y-intercept? Set x to 0. So when I set x to 0, kills off the first term. I'm left with -6y is 12. Divide quickly by -6, you get -2. And as soon as you have 2 points, right, you draw a straight line. So I would argue that finding the intercepts on this problem is easier, when in terms of graphing, is easier than going through and solving for y. That's what I would say. I don't know how you feel about it. I would never force you to use one way. I would just say graph the line. And I don't care which way you do it, as long as it's correct. How about this one? So you can start to get the hang of this pretty quickly. If I want x-intercepts, I'm going to let y be 0, right? So imagine that's not there. Solve for x. What do you get? -4/3. So I have an x-intercept of -4/3, which is hard to graph. That's really hard to graph. It's like right in here, right before -1, -4/3. It's too small to graph on that, right? Oh, what is it? What did I say? 4/3. What did I just do? -3/4 in my brain? It's -1 1/3. A little bit bigger than -1. A little bit smaller to the left. And then to get the y-intercept, you just cover up this x thing. It's gone. Y is what? 2. Draw a line. You're done. How about this one? Find the x-intercept. Let y be 0. How do I solve that for x? Okay, so times both sides by what? So what would you get? X is 8. Well, that's pretty quick. Okay, now cover up the x term here. And y is what? 1. You see how much quicker that is? Now, that's what I would do. I would try to do this if I see my x and my y's together on one side. That's the technique I like to use. Now, this method is the one we did last class. Graph using slope and y-intercept. So we already did this. See, now, if I asked you to graph this one right now, okay, and I didn't tell you which method to use, what method do you think you would use? The zeros, right? Well, the x and y-intercept. Just replace the 0 in there. Because look how quick it works. If you x-intercept, cover that up. What do you have? Divide by -3. So you get what? -5. And then if you want to find the y-intercept, this will go away. -3. I'm done. Compare that to this, which is -5y. Move your x over. Then divide both sides by -5. So 3 over -5x minus 3. And then plot your -3, then use your slope. There's a lot of room for error there. A lot more room for error than there was by just plugging in zeros. All right, I'm not going to do any more of these because we did those last class. I feel homework coming. Yes. No, I'm excited because I feel like that means we're... Is this done? Well, why was I in such a hurry last class? No, there's more? Okay, there's more. Dun, dun, dun. Okay. Well, let's see what... So look at all of these on page 57. So add this to that. I mean, number one, all of these, find the zeros. Find the zeros. Those are all fair game. Just practice. I mean, that's all this is. The what? Wait, send you the what first? Well, yeah, I guess so. Lines, you get lucky with lines, because with lines, replacing x with 0, y with 0 is pretty simple. Once they aren't lines anymore, that goes away. And so you have to have the other approach, which is more involved. What is this? Determine if it's slope positive, negative, 0, undefined. What's the slope of this? Here? 0. And negative. Vertical line. Straight up and down. Reminder, graphing using slope-intercept method. So we already did slope-intercept, right? Plot the y-intercept and then do your rise over run. So I would say do a couple of those. Is that all? Just remember that on your test, I'm not going, when I tell you to graph a line, I'm not going to tell you use this method. You use what you want. But a lot of times the equation itself will dictate what you do. Like if you had this, you probably do the plug-in zeros, right? If you had this, well, I mean, you could plug in zeros here also, but I mean, this is just go to 2, right? And then slope is up 3 over 1, and then you've got it. So it just depends on how it's presented. Okay, applications of linear functions. So when they say applications, what do you start thinking? Word problems? Word problems. In order to get credit, you must solve the problem's what? I don't know, question. Right? There's going to be a question in the word problem. You must solve that. You can't just at the end say X is 2. You have to say 2 sheep or whatever it is. You know, like, yes. Whatever the problem's asking, you have to solve it at the end. You can't turn the question into math and then never take the math back to the answer. In order to get credit, you clearly define variables, set up equations, state solutions. Must. Clearly define variables, set up equations, state solutions. Here we go. The length of a rectangle is 4 inches longer than the width. Let X be the width. Then what's the length? So the length of a rectangle means equals 4 inches longer than, that means 4 inches more than, right, the width. So the length equals 4 more than the width. But they're saying let the width be X. Do y'all see that? From the words into the equation. The length is 4 more than the width. So over here, length is 4 plus X. How about this one? The length of a rectangle is double the width. L equals, so the length is 2X, and you're choosing X to be the width, right? You're assigning a variable to the width, you're calling it X. I would have called it W, right? But X, we like it. We like X. So that means the length turned out to be 2X. The length of a rectangle is 8 inches less than the width. Take your time. The length of a rectangle is 8 inches less than the width. X minus 8 or 8 minus X? This is going to be the thing that's going to trip someone up. I'm going to write them both, and which one is it? Why is it X minus 8? 8 inches less than. I thought 8 inches less than meant 8 and then minus. Yeah, you have to think about what this is saying. If I say that I am 8 inches less than your height, right? That's right. It's your height minus the 8 inches. So just because the 8 appears first doesn't mean that it's going to be first in the equation. So the minus is the one that's the most tricky. So make sure if you don't know, if you're confused, think of it the way I just thought, presented it. If I say I'm 8 years younger than something or someone, then that means you're going to take that person's age and subtract 8. Yes? So it should be which one? X minus 8. Where X is the width, right? And then X minus 8 is the length. The width of a rectangle is 5 inches less than twice the length. So you want to go to W now? That's fine. W, that's the width of a rectangle, is, what did you say? 2L minus 5. Is this 5 inches taken away from or less than twice the length? Yes. So in this case, the width we call W, and the length turned out, what is the length? Sorry, we haven't done that yet. What is the length then? That's right. You would have to solve for L, wouldn't you? Wouldn't you have to solve for L here? I mean, look at these right here. The reason why we just left X, 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 and then over here, the length was this equation is because it was already solved for L, wasn't it? In this problem, we have W here. We use W instead of X, which is fine. But now if we want to know what length is, we have to take this equation and solve it for L. It's not solved for L, it's solved for W, isn't it? So I could do, what, W plus 5. Let's take the 5 to the other side. Then all divided by 2, which I will write as 1/2 W plus 5/2 equals L. That's what L would be. What we're trying to see is that all of these problems, when you look at them, kind of step back, this right here looks like y equals, here's mx plus b. You have a letter, L, which is y. We have a number in front of a variable, mx, plus a number. This is a line. That's the relationship. It's linear. All of them are like that, right? L equals 4 plus x. This is our b. This is the m is 1. Here, m is 2. What's b? I lost you. 0. Good. This one, m is 1. B is -8. So these are all linear relationships.
Which makes sense because it's talking about the side of a rectangle, which is a line.
Well, it's because the relationship between them, if one of them changes the other one, the way that wording was, it works out. Okay, solve the problems algebraically. What they mean by algebraically is don't guess and check. This isn't just a guessing, oh yeah. I mean, in real life, if you could do a guess and check, then you would, but all right, at the end of the day, a vendor had 157 coins consisting of nickels and dimes, worth $11.35. How many coins of each type were there? Got 157 coins, nickels and dimes. 1135 is how much they have. How many coins of each type? So, a couple of things that we know. There are 157 coins, right? What we want, how many coins of each type were there, right? We want the number of nickels, we want the number of dimes. That's how many we want. I mean, that's what we're looking for.
So n times 5 plus d times 10 equals 1135?
Well, let's first assign the variable. You sound like you want to use n for nickels and d for dimes. Does that all sound good to you? So what we're going to be trying to solve for is n. We're going to assign the variable n equals number of nickels, right? Was it nickels and dimes? Yeah. And then d is, I'll use little d, number of dimes. All right, so what is the first fact? Tell us we have 157 coins. What equation can I set up, if any, with this fact? Can I set up an equation with this fact? N plus D must be 157, right? N plus D must be 157. Now, I don't know what N and D are. I mean, I could have 100 nickels, right, and 57 dimes. That would be a possible way of getting 157 coins, but I need them to add up to be 1137. So let's see what equation we can make out of this. So 0.05 N, that's 5 cents per nickel, plus what? 0.10 D must be 11.35. Well, that's what I was going to suggest we do now, right? I was going to suggest we do that. But are you all okay with that? That's however many nickels we have times 5 cents, times, or plus, however many dimes we have times 10 cents, that should have to be 1135. All right, let me move the decimal over. And remember, we just look and we say, okay, what? How many places? 2? So what's my new equation? 5N plus 10D equals 1135, right? 1135. That's right. That's right. That's how many pennies you have. Uh-huh. Now, we haven't solved the problem, though. Notice we have 2 equations, don't we? On one hand, I know that the number of coins together is 157. I know on the other one that somehow you add up all the money and you get that. Yes, what you can do now is you can take this first equation and solve it for N or D, your choice. Which one do you want to solve for? N? Okay, so would you agree that from this equation, N is equal to 157 minus D? So if that's what N has to be, right? In order to make the first equation true, N must be this. Then I can rewrite the second equation and I can replace the N in the second equation with 157 minus D. So now take your second equation. 5 times, what did we say the N is going to become? 157 minus D. And do I need that in parentheses? Yes, because the 5 is going to distribute to both. Plus 10D must equal, I'm running out of room here, 1135. Are there any questions? Because this is a really critical problem. You have the original information gave us 2 equations. We took one of them and we solved it for one of the variables. In this case, we chose N. We took that result and we plugged it into the other equation and came up with this new equation. Now, what's good about this new equation? Well, what was bad about this equation? Couldn't solve for N or D exactly because we didn't know them both. Here you have a new equation. How many variables appear in it? Just one, and it's linear, and you should be able to solve this. You multiply through by 5. What do you get? 70? No? For D. If you solve this, which we won't do, that's order of operations, right? Remove parentheses, collect like terms, isolate variable, all the steps to solve a linear equation. I'm being told 70 is what D is. If D is 70, then what's N? So yeah, go back to this equation right here. We know D now, though, don't we? N is 157 minus 70, which is 87. So we should have, now this is where I was saying you have to answer the question. You have to go back and you just don't want to put D is 70, N is 87. You want to write down somewhere, 87 nickels, 70 dimes. How could we check the answer? Yeah, multiply it out. No, this is $7, right? 7 dimes. And these are nickels, so does it work out? Add them together, make sure it adds up to 1135. Also, when you add the two together, you should get 157. This reminds me of an incident that happened when I was rather young kid. My family used to have this tradition of going to eat Chinese like on the weekends. Like we try and do it like once a week. Family would all get together and go eat Chinese, right? And they sell the little Chinese candies at the counter. So my dad went up there. I'm standing next to him. My sister loved Chinese candy, and he said to the lady back there, he's like, "How much Chinese candy do you actually have in this building right now?" You know, and the lady's like, "Oh, we've got this big box." You know, she pulls out this huge box underneath the counter, like full of Chinese candy, right? And he looks at it for a second, and then he's like, "I'll take everything. I'll take your whole box," right? And she's just like, "What?" You know, and then he handed her, I think it was like $2 or $3. And she was like, "Oh no, it's more than that," and all this stuff. Well, here's the moral of, or the story, the reason why I'm telling you this. They had like this jar that they had the Chinese candy in. They were individually packed, and it said on it at the time, it was a long time ago, I don't remember exactly. I'll just kind of make it up. It was like that. So, no, per candy, you know, that's what it said, right? What's wrong with that? If you're running that business, what's wrong with that? What does that mean? That's not 5 cents. That's a lot less than, that's actually 5/100ths of a cent. Right, look, the cent symbol means, if I want to write 5 cents properly, that's the way to write it. If I want to write it using 0.05, then I need to write $0.05. $0.05 is 5/100ths, right? Remember place value, tenths, hundredths, 5/100ths of a dollar. Well, 5/100ths, what's 1/100th of a dollar? 1 penny. So 5/100ths would be 5 pennies. That makes sense, right? So this writing right here really means 5/100ths of a penny. 5/100ths of a penny. What? So how much could you get for 1 penny then? Think about it this way. If this is, how many times does 5 go into 100? 20 times? 5/100ths of a cent is 1/20th of a cent. So this is, I could buy 20 Chinese candies for a penny, is what this is saying. And my dad handed her like $2. How many pennies are in $2? 200 pennies. And I get how many per penny? 20? So he could get 4,000 Chinese candies for $2 because of their mistake, right? Now, of course, he didn't demand it. It was a lesson to them, like, you need to change that. That's what he was telling them. But, well, no, just, this has nothing to do with, this happens everywhere.
But I don't think they use sin in China.
What makes you think that they're from China?
Well, there's a Chinese restaurant.
That doesn't mean they're from China. Right? I mean,
I'm just saying I don't think they use sin.
Math is universal. It doesn't matter. The point is that this type of thing happens more than you think, right? I mean, it happens. You see, or I see it. You probably don't pay attention, don't care. Yeah, of course. Yes, yes. All right. So, where are we? We almost there? Well, I'm thinking that we may not need a break today. I'm thinking we might actually just get to the end here. The end and be done. Where's the homework? Does it start here? No. Okay. Couple of more examples. Okay, let's do a couple of more examples. I won't do number 2 because it's another coin one, except you're using quarters and dimes, so you can set that one up exactly the same way. I like this problem. This is a good problem. Both of these are good problems. Um, 62. Let's see if we can just at least set this one up. Phil has $1.35 worth of coins in his pocket, consisting of nickels and dimes. The amount of dimes is one more than double the number of nickels. How many dimes does Phil have? Who cares? He only has $1.35. He's broke, right? All right, so Phil, what does he have in his pocket? Or what are we trying to solve for? Let's assign some variables. Okay, so we're going to go back to, hold on, we're going to go back to this. N is nickels and D is dimes. Number of dimes. So what were you saying? What does the 135 tell us? Is that right, everyone? Okay. Yes. We know that the amount of money comes from 5 cents per nickel, 10 cents per dime. So we need to write it as 0.05 N plus 0.10 D must be the $1.35. That's what you were trying to say, yes? Everyone agree with that fact? $1.35, nickels and dimes only. This is what it has to look like. Move all your decimals over. And that's our first equation. Now, what's the other fact? The amount of dimes is, isn't the amount of dimes what we're looking for, number of dimes? Is one more than, what does that mean? Plus 1? Add 1 to what? Double the nickels, 2N. That's your second equation. I put the fact, I put it where the fact is, but that is a fact, isn't it? So how are you going to do this? You have 2 equations. You're going to solve one of the equations for one of the variables. Well, look at this. One of the equations is already solved for D, isn't it? So we shouldn't invest time trying to solve an equation for a variable if it's already done. So notice in the problem we did before, this equation was not solved for N or D, right? This one was not solved for N or D either. So we had to force it to happen. On this problem, one of them is already solved. So what I'm going to do is I'm going to rewrite this equation here, 5N plus 10, but replace the D with 1 plus 2N in parentheses, right? Do not forget the parentheses. And then you go through and distribute. Collect like terms. Move things over. I'm getting n is 5. Anyone get that? N is 5. Once you know what n is, how do you get d? Right back here. Right back into this one. See, this one's solved for d. So just plug this n in for d. So d must be 1 plus 2 times 5. So d is 11. So my final answer would look like this. 5 nickels, 11 dimes. Questions? Excuse me. Yeah, pretty much all these problems with coins. Let me take a look at this next thing, see if it's something I want to do. Is that the last page right there? I think if we do this one and this one, we can say we're done. Does that sound okay? Can y'all do it without a break? Yes? All right. So I'm not gonna fill all this in, all right? What I want to do is just get straight to this problem. The tuition at college XYZ is $100 per credit and a $75 student fee. So you have to understand a little bit about the way college works, right? Every class you take has so many credits. This class is how many credits? This one, the one you're in, sorry. This one is a 3-credit class, right? If you take calculus, it's a 4-credit class, which means it's longer. You know, like if you do a calculus class, you're in there for an hour 40 minutes in a normal class. Here, it's for a class like this, normal semester, it's an hour 15 minutes. Okay, so at this particular college, you pay $100 per credit and $75 student fee. So the question first is, what is the one-time charge, or what we call the fixed cost? $75. So it doesn't matter if you enroll in 3 credit hours or 12 credit hours, doesn't matter, you're going to pay the $75 regardless. What is the variable cost?
Amount per credit, so 100 times fee. Fee credit.
You want to use credit? They use, in the next question, they use X.
Okay.
So I'm going to just use 100X. $100 per credit hour, right? So if you take 1 credit hour, you're going to pay $100. 2 credit hours, 200. 3, 300, 4, 4. That's changing, right? That's variable. That depends on person to person. So what is the tuition total as a function of X? 100X plus 75. And what type of function is this? Linear. It looks like this, doesn't it? In fact, I could ask you to graph it. How easy would this be to graph? But I'm not going to. I'm just trying to get you to see a basic picture of this. You would go to a y-intercept. Yeah, this is all the same stuff, just different versions. So here we go. And then what's the slope? Up 100 over 1. Very steep slope, right? 175, 1. So I could do something like that. That would be the next point. Let's say that's 1. And then you keep going, right? And that line just continues. But see, what's different about this and what we've talked about before is that it doesn't make sense to put the line on this side, does it? Because you don't take negative credit hours. So this really only makes sense if you've got something going on the right side. But at the end of the day, it's linear. It's a linear graph. Joe has a part-time job caring for and walking dogs. He estimates that his annual insurance is $420. On average, he spends $4.50 on gasoline per visit. He charges $15 per visit. What is the one-time charge or fixed cost? These are all estimates, though, right? He's trying to predict what his business model looks like here. So he's got to carry insurance, right? Once a year, he has to pay for that insurance, $420. That doesn't matter whether or not he walks 1,000 dogs or 2 dogs. He's going to be paying $420 for the insurance. So this is the $420, right? Then he has variable costs. He spends $4.50 on gasoline per visit, and he charges $15 per visit.
Why don't we just do that math right there first? It's the 15 minus 450.
Can we?
Take out your overhead first, right?
Yeah, sure. I mean, if he already knows I'm going to make $15 every time I go walk a dog, but it's going to cost me $4.50 every time I walk a dog. So just subtract the two, and what would that be? $10.50. So we're doing that. We're doing 15 minus 450 is 10.50. But then that's what? Per visit. And let's use X again. X would be the number of visits. 2 dogs, I guess. So what's the cost function? $10.50x minus 420. That's the critical part. Look at that. Why is it minus? That's right. This is actual what he has to pay out of his pocket, right? He has to pay for that insurance. So that 420 could be viewed as a negative. Now, I didn't want to put negative there until after we got to the cost function and identify, hey, look, you can't put plus, right? He's not making $420 a year for insurance. He's spending it. So up here, please put a negative on that so you understand this is a cost, right? It's not a profit. The 1050x, now that's money coming in. That's why we keep it positive. So if I were to graph this, what would it look like?
Start way down to 420.
Negative 420 way down here? And then it would go up 10 over 1, and you would have something like that. What does this point right here represent? That's right. That's how many visits he's going to have to do before he starts making money. He makes money after that. Now, how could you find that point? So what is this? This is the x-intercept. How do you find the x-intercept of this linear function? You replace y, which is this side, with 0, and you solve for x. You see? Let's find his break-even point, and then I'm going to say it's done. What's the break-even point? You replace the left side with 0? Add 420 to both sides and divide by 10.50. Is it 40 even? By the way, this was the answer to the question, the cost function. But he would have to do 40 dogs before he would break even. Yeah. Okay. All right, that's it. Let's say that's it. And what I will say is for this last section of stuff, I told you that these 2 problems were good, coin problems, right? And then for this, maybe something like that where you have to come up with a cost function. you can kind of ignore the rest of this because we'll come back and talk about it later. But all right. Well, any questions on the homework? I mean, homework or what is going on? Okay, hold on. I'll get back to that. When do we what? On the day of the test? No. Oh, yeah, sign-in sheet. Yes. How about I'll call names today? Make it a little quicker. Wilson Freeman. Jennifer V. I can't pronounce that. Doi? Okay, got you. Here, everyone says here. Hannah Trinidad. Okay. Nicole T. All right. Sean Sullivan. Marina. No go. Oh, wait, hold on. I should stop my video. No one wants to listen to me call names.